Hello everyone, this is lesson 5.5, Inequalities in One Triangle. The next lesson we will be doing inequality theorems in two triangles or between two triangles, but this lesson is just between one triangle. So this lesson explores how the longer side of a triangle is opposite of the bigger angle and working with that relationship there. And then using that to also determine side lengths of a triangle. So we know that if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite of the shorter side. Vice versa, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite of the smaller angle. So the bigger the angle, the bigger the opposite side is going to be. The smaller the angle, like you can see in this triangle, that R is smaller, and that's because 8 is the smaller side. So this says list the angles in order from smallest to largest. So we know since 8 is the smallest side, R is the smallest angle. So we'll say angle R, followed by angle Q, because 10 is the next largest side, and then the largest angle would be angle P. Okay, for number 2, 18 is the smallest, so angle H is the smallest. And then next would be angle F, and then finally angle G, because it's opposite of the longest side. For number 3, both A and B are the same, so we can just say angle A is congruent to angle B. This is an isosceles triangle, so those would be the base angles, and then angle C is the biggest. Here, list the sides in order from longest to shortest. So here, if we take 81 plus 17 and subtracted it from 180, you would get 82 degrees for angle A. So that means AC is we're doing longest to shortest. So CB, or BC, would be the longest side because it's opposite of the biggest angle, and then AB, and then followed by AC. For number 5, 96 plus 41 subtracted from 180 would give us 43 degrees for angle S. So that means 96 is the biggest angle, so ST is the longest side. So ST followed by RT, and then followed by RS as the shortest side. So within a triangle, you also could possibly have side lengths that don't form a triangle. So I don't know if you knew that, but not all pairs of side lengths can form a triangle. They have to follow this rule that we are going to learn called the triangle inequality theorem. So here, as you can see, the longest side is 5 and then 4 and 2. They will make a triangle, but if you shorten the sides, I'm going to jump over to here to be 3 and 2. If you try to meet them, they will meet right here. So that will not form a triangle. If you make them even shorter, they're not even going to meet. So that will not form a triangle as well, even if you try to reorient the sides in a different way. So the idea of the triangle inequality theorem, it says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So the other two sides have to add up to be a number greater than the third side, and that has to be a combination of all 3 possible combinations of sides, like in any order of adding them. So our theorem says that A plus B has to be greater than C, A plus C has to be greater than B, and B plus C has to be greater than A. All 3 of those must be true for it to form a triangle. So let's check here. Is 3 plus 5 greater than 4? Yes. Is 3 plus 4 greater than 5? Yes. Is 4 plus, here actually let's write it out. 3 plus 5 is greater than 4. 3 plus 4 is greater than 5. And 4 plus 5 is greater than 3. So yes, these side lengths do form a triangle. If any one of those weren't true, it wouldn't form a triangle. So here, 17 plus 17 is that greater than 34? No. Even though 17 plus 34 is greater than 17, one of these doesn't work. So no, it does not form a triangle. For number 8, if you take 6 plus 50, that is not greater than 39. So the answer would be no. Okay, you can also determine possible values of the third side using the triangle inequality theorem. So you know if you add the two together, you would get the biggest possible length. And if you subtract them, you would get the, sorry, I meant to say 6. You would get the smallest possible length. So that means that the triangle can be anywhere between 3, the third side could be anywhere between 3 and 15, but not equal to 3 and 15. So the idea also is like this. If you take 5 plus 5, that should be greater than the third side. And if you take 5 plus the third side, that should be greater than 5. You could do it a third way if the 5s weren't the same, but they are here. And then if you solved it, you'd get 10 is greater than x. And also here, you would get x is greater than 0. So for this one, x has to be in between 0 and 10, not including 0 and 10. Let's try that same thing for number 11. 9 plus 18 has to be greater than the third side. 9, and then let's go ahead and, well, we'll solve it next to it. So 27 is greater than x, or x is less than 27. 9 plus x is greater than 18. So that means if you subtract the 9 over, x is greater than 9. And then 18 plus x, the third combination, has to be greater than 9. So x has to be greater than negative 9. So usually for these, you're always going to get one that would give you a negative answer, and that would be that. So we're just going to ignore that because x cannot be negative. So that means that x has to be in between 9 and 27. All right, the next page has some examples of finding, actually this says list the sides in order from shortest to longest. So this angle for angle A would be 35 degrees. And if you subtract these two from 180, you would get 60 degrees for this angle. So the shortest side would, like, within this triangle, the shortest side is BD, but that's the longest side of this triangle. That means that this triangle is smaller. So the smallest side in the whole figure is opposite of the 40-degree angle, so CD. So right, CD is smallest. I'm just going to say the length of CD, and then followed by BC, followed by BD. And then after that, we're in the bigger triangle. And then the next longest side would be AB, opposite of 70. And then the next biggest, or the biggest, would be AD. Okay, for this triangle, we're going to start down here. This angle for angle A would be 30. So that means ED, opposite of that, is the shortest side. So ED is smallest, followed by AE, and then followed by AD. And now we're in the medium-sized triangle. So this angle here is 65, which means that AB is the next largest side. And finally, opposite of 75 would be BD. Then between the two you have left, BC is smaller because 60 is less than 80. And then DC, CD is the biggest side. All right, number 14, describe the possible values of x. So we can set up equations just like we did for the last page of the different possible combinations, or which would give us what x should be. So we know that 8 plus 18 has to be greater than 4x plus 2. Let's go ahead and solve that. So if I subtract the 2 over from here, that's 26 minus 2, which is 24. Divide by 4, and you get that x is less than 6. Then I'm going to try another combination. So I'm going to say 8 plus 4x plus 2 is greater than 18. And if you simplify that, you would subtract 8 and 2, so subtract 10 over, and get 4x is greater than 8. So x has to be greater than 2. If I try the third combination, 18 plus 4x plus 2 is greater than 8. That would be 20, and if I subtract 20 over from the 18 and 2, we would get negative 12. And that would give us a negative answer, so we're going to ignore that one. So you have to put the inequality together as a compound inequality, starting with 2, always least to greatest, 2 to 6. So x can be in between 2 to 6, not including 2 and 6. Okay, for number 15, it says if the measure of angle A is that, gives us measure of angle B and C, list the sides in order from longest to shortest. So I'm going to draw the triangle itself, just a generic triangle, and I know that the angles add up to 180. So I'm going to add up these three expressions and set it equal to 180 to figure out what the x is, plug it back in to figure out the angle measures, and then we'll look at the sides. So 5x plus 6x plus 1x would give us 12x. And then we've got negative 10 and 20, which is 10, plus 2 is 12. So 12x plus 12 equals 180. Subtract the 12 over to get 68. Divide by 12, and you get x equals 14. So if x equals 14, then we can plug in the sides. So 5 times 14 would be 70. Plus 2 is 72, so angle A is 72. And then 6 times 14 would be 60 plus 24, which is 84, minus 10 is 74. So angle B is 74. And then angle C would be 34. So then we'll list the sides from longest to shortest. So since angle B is the biggest, side AC will be the shortest. Followed by, I'm sorry, I meant the longest. AC is the longest, so our inequality needs to go the other way. Followed by angle A, which opposite of that is BC. And then finally, the shortest side is AB. Okay, the last question on here is just about perimeter. So you would add them up and set them equal to 27 and then list the angles in order from least to greatest. So as your exit ticket, I will let you try this question on your own. And after that, you can work on the 5.5 Pear Deck homework. Thank you for watching and have a great day.